Hi, this is Matthew from BMI Academy. Question 2. It says define the refraction of light. And that's quite straightforward, right? What's refraction? Refraction itself is the transmission of a wave from one medium to another medium. Okay? Transmission of a wave from one medium to another medium. Or you can say it is the bending of a wave when it moves from one medium to another medium. You get that? And these two media have different what? Optical densities. Okay. So I'll say 7A, a refraction is the transmission of a wave from one medium to another medium of a different optical density, a different what? Optical density. Right. So 7A Roman figure 2. This is Roman figure 1. Let me indicate it properly. 7A Roman figure 2 says, what is the relationship or what's the relation between refractive index and speed of light in a medium? That's quite straightforward. We've talked about that earlier. 7A Roman figure 2. Refractive index that they're talking about is what? Absolute refractive index is equal to what? Speed of light in vacuum over speed of light in a medium. You can write it out fully. All right, this is number n. Absolute refractive index is number n. C over what? Cm. This C means what? Speed of light in vacuum. Why C subscript M means speed of sound. Sorry, did I say sound? Light, I mean. Which kind of error is that? So we have speed of light. Speed of what? Light in vacuum. This one means what? Speed of what? Light in a medium. Okay. Next question says, what is an optical fiber? That's B from our figure 1. Okay. I explained a bit of this before. Optical fiber is just what? A flexible material, a flexible material made of glass or plastic. That is used, for transmitting signals. That is used for transmitting signals from one point to another. Where total internal reflection total internal reflection. So that's what optical fiber means. B, Roman figure 2. It says, give one reason why a cladding material is using optical fiber. Give one reason why a cladding material is using optical fiber. Okay, that's B, Roman figure 2. So why do we use cladding material in optical fiber? The straightforward answer, reason. The straightforward answer is because it has a lower optical density compared to glass. Now, if you can recall, optical fiber works on the basis of total internal reflection. And for that to happen, a ray must travel from a region of higher optical density to a region of lower optical density. So if we have the inner part to be glass, to be made of glass, then the cladding, which is the outer part, must be of a lower optical density, such that a ray that is coming from glass towards the cladding is going to be a movement from a region of higher density, that's optical density, to a region of lower. So this will create an internal reflection, which will allow the signals to be transferred from the source to the destination. B, Roman figure 3. It says, state one use of optical fiber. State one use of optical fiber. B, Roman figure 3. The straightforward answer to that should be, it is used for the transmission of signals. Transmission of signals. So we can also say for viewing internal organs in medicine. The question requested for one, just write only one and move on. The Roman figure 4 says, state the two conditions required for total internal reflection to occur. I've already addressed this. As a B, Roman figure 4. The two conditions, critical angle must be exceeded. Critical angle must be exceeded. As where I said, I has to be greater than C. Then, and I also say ray must travel from a denser medium to a less dense medium. Ray must travel from a denser medium to a less what? Dense medium. But to air, glass to water, water to what? To air, in that manner. Okay. Then C part of the question says an object is placed 25 centimeters from a converging lens for case 1, and 2, there should be a semicolon here. 2 diverging lens, each of focal length this. So both of them have F to be 15 centimeter. This also what F to be 15 centimeter. But take note, we are dealing with lenses here. Lenses, okay, have similar characteristics to what? To mirror. A converging lens has the same characteristics with converging what? Mirror. A converging lens is a convex lens. So this one is going to be positive. Why for a divergent lens, this is going to be what? Negative. Just take note of that as the convention. So it says calculate the image distance and the lateral magnification produced in each what case. Calculate the image distance and the lateral magnification produced in each case. Also state the type of what image produced. Okay, so that's not a problem. What else did the question supply to you? It says place 25 centimeter from the lens. So which means U is given as what? 25 centimeter, right? So we'll just go ahead and use the what? Formula. Okay, so the formula, where is it again? Sorry. Okay. Where's the question again? Did I jump the question? Okay. That's C part of the question. Okay, C part of the question. So we'll go by saying C. We have U to be equals to 25 centimeter. We have F to be equals to 15 centimeter. So Roman figure 1, we are dealing with a converging lens. Converging lens. That means F is equals to what? Plus 15 centimeter. So we need U. So we say 1 over U plus 1 over V equals 1 over F. So from there, 1 over U equals 1 over F minus 1 over V. So that means 1 over 15 minus, sorry, what we need is actually V for the image. So I should have 1 over V to be equals to 1 over F minus what? 1 over what? U. So 1 over 15 minus 1 over what? 25. You get that? Okay. So in that case, you can choose to find the LCM, a choice, or you can choose to use your calculator, see your choice. All right. The LCM here should be like that's 75, right? 15 in 75 is 5. 25 in 75 is 3. So we have a 2 over what? 75. Okay. So if that is the situation, you're going to have it that V itself is going to be 75 divided by 2. That makes it what? 37.5 centimeter. So that gives us 37.5 centimeter as the answer that we are looking for. Okay, I hope we didn't make an error there. And for the second case, we are dealing with a what? A diverging lens. On figure 2, it's a diverging lens. So for a diverging lens, we have it that our F is going to be negative, so that's minus 15 centimeter. We still need the V. Going back to the question, I just remember the question asked for not just the image distance, it still asks for the lateral magnification. So let me just quickly do that for the other. The magnification here is going to be V over U. And what's our V? Our V is going to be what we just calculated, 37.5. And our U is 25. So we just need to press the calculator for that. So I have a calculator here. So and just punch that in the calculator. You have 37.5 divided by 25. So that's 1.5 or 3 over what? 2 without a unit. Then Roman figure 2, we go through the same process. 1 over v is going to be 1 over f minus 1 over u. So that's going to be 1 over negative 15 minus 1 over 25. The LCM is 75. 15, 75, 5 times that, negative 5. Minus 25 in 75, 3 times that, 3. So we have 1 over v to be equals to negative 8 over 75. This then implies that v equals to negative 75 over what? 8. Okay. If we choose to put that in decimal form, we are going to have it as a negative 9.375 centimeter. So this is more or less like saying you have 9 point what that, but you have it in, I can call it 9.375 centimeter. Then I'll say virtual. Why is it virtual? Because I got a negative value for the value of v. Don't forget that the question says you should state the type of what? Image produced. Yeah. So for the first one that we calculated, this was positive. That makes it real, right? So, but for the second one that we calculated, we got negative. That makes it virtual. So our M, I have absolute what? Let's put it in absolute form. Absolute V over what? U. Our V is 9.375 centimeter divided by U. What's my U? My U is 25. So what do we have here? 9.375 divided by 25. So that's practically less than 1, 0.375. So this means diminished. It's diminished. This first case that we calculated, we got a value greater than 1. This is magnified. And I also needed to know that real images most time are usually inverted. This will also be inverted. Now, don't let me go write it here so that you don't get confused. It is also inverted. For this case that we have it to be virtual, is real. If you go through the properties of the images that were done earlier, you'll realize we had real, for the cases where we have, what's it called? For the cases where we have virtual images, they were erect, diminished, erect.